Welcome back to Anatomy Physiology. We're starting Chapter 13, and for the next couple of chapters we're going to be talking about the brain, the spinal column, the cranial nerves, and the spinal nerves. I like this picture for so many reasons, not least of which I have a friend who's an insomniac, and so I'm constantly getting texts at 2, 3, 6 in the morning saying, "You up?" Meaning, are you ready to talk? Are you ready to text? But the other thing is, can you imagine taking all of the muscles and leaving just the nerves? This is phenomenal. This is amazing. Your brain, your eyes, the spinal cord, and look at all the spinal nerves coming off. In lab, you should have gone over the 12 cranial nerves, and there's a variety of ways of memorizing them. There's little mnemonic, little sayings that you can do. They have 12 Roman numerals, and they mostly control things in the face. Although if you look at number 10, the vagus nerve is actually controlling smooth muscles. So it's super important. This happens to be a picture of number 5, the trigeminal. So it branches off, 1, 2, 3 branches, and then it branches off from there. And some of the things that the trigeminal nerve is responsible for is controlling your facial expression. And in this case, this person has an inflammation here where it's kind of like carpal tunnel, where it shuts off the feeling into your hands. This shuts off the feeling into your face, and this person is experiencing Bell's palsy. So that side of the face is drooping. The mouth is kind of hanging open on the side, and you don't feel that you're drooling. But because your mouth is kind of hanging open, you tend to drool. Now, if you can get the inflammation to go down, then you should get the feeling back in your face, and it will resolve the Bell's palsy. But people who experience it think they're having a stroke because they lose control of half of their face. This chapter, we're mostly just talking about the spinal cord and the spinal nerves. So there's many more of them than just the 12 cranial nerves that we just looked at. We'll also talk about your reflexes. So I thought this was kind of funny, where he hit him and says, "Well, your reflexes are good." And then here's someone who slept funny and they can't pull their head back over. So this is an interesting condition. There's actually something called wry neck, W-R-Y, and it pulls your head over onto your shoulder. And I've actually had 2 of my relatives have it right before they passed away. What do you do with your spinal cord? Well, one of the things that you do is you conduct information up. That would be your sensory, and then down, that would be your motor. So we talked about afferent and efferent. Afferent is where you get a sense that you're going to carry up to the brain to process. And motor is where the brain cell tells the skeletal muscles to move and do whatever it is that you need it to do. So you conduct. Another thing that is amazing that our nerves do is we have spinal neurons that get information from all sorts of different stimuli, and they integrate the information and tell your body what to do. They give it an appropriate output. So in the case of a bladder, you're sensing how much urine is in there. You're telling the sphincter to stay closed so that you're not dribbling urine. So there's so many different things that are coming in, and you have to process them all so that you have bladder control. Or in the case of walking. Imagine walking where you have to have repetitive sequences of contractions. And you've got over 600 muscles. So when you're walking, think of all the different muscles that you have to talk to, you have to communicate with from the brain and through the spinal column. And then we're going to spend some time talking about reflexes. So these do not require the brain. They just go through the spinal cord. So you get some sort of a stimulation. It goes through the spinal cord, comes right back out, and causes an effect to occur. So you don't have to stop and think about it. If you put your hand on a hot stove, you're going to reflexively pull your hand off. You don't have to leave your hand on the stove while you think, wow, this is really hot. And the information goes to your brain and says, yeah, man, it really hurts. You're burning things. I'm feeling heat. I'm feeling pain. And then the message goes back down the spinal cord. By that time, you've really hurt yourself. So luckily, we have these reflexes where they just go out, they process that there's pain, and they cause you to pull your hand away before you even realize why you pulled your hand away. And then the information will go on up to the brain, and it processes and says, wow, that was really a dumb thing to do, to put your hand there. This slide is kind of a review of some of the stuff we've learned in other chapters. So we know about the foramen magnum, which is the large hole at the base of the skull. So from there down, we call it the spinal cord. And for above that one, then you have the medulla oblongata, and you have the midbrain, and the rest of the brain up there. There are 31 pairs of spinal nerves, and if you stop and think about how many vertebrae they are, then you'll be able to figure out where these are. This is an interesting picture because it shows you where they've cut away the vertebra, so you can look inside. Here's the spinal column, right there, the spinal cord, and coming off of it, you can see the spinal nerves coming off, and they're bundling. You can see dorsal root ganglia right there. So you have cell bodies or soma within the spinal cord, and then you come out and you have another connection in here with cell bodies of other nerve cells. So this bundle is the cell bodies or the soma of connecting nerves. Neurons. Let me take a second right here to remind you what the difference is between a nerve and a neuron. So back in my day, when you talked about nerves, you actually talked about the nerve cell itself. But they've changed that, so now when you want to talk about a nerve or a nerve cell, you have to use the word neuron. And that's to keep you from getting confused with what a nerve is. A nerve is a bundle of axons. So here we have some axons coming together, and we're going to bundle them together. The nerves, which are the bundles of axons, come out off of the spinal cord, right there, coming off. And as the nerves or the axon bundles come on out, a lot of times they join back together and make a plexus. So this one happens to be the brachial plexus. It's going to go down your arm. Up here, if they had finished drawing them out, you would see that there's a cervical plexus right here. Coming down here, there's a lumbar plexus in this region. So if you saw these coming on out, they would join together in the lumbar plexus. And then you have the sacral plexus down here where they rejoin. So here they are coming out, and here they are joining into this plexus. If you break the spinal cord, if you actually sever it, from the place that you sever it on down, you are paralyzed. So a lot of times people get in an accident and they break or sever the spinal cord in the region of the lumbar area, and so they're going to be paraplegic, where their legs don't work. If you break it up higher, you can end up being a quadriplegic, and your arms and your legs don't work. And of course, if you get too high up and you break your spinal cord, then you don't survive. Another thing that I want to point out that's a little bit confusing, you have 7 cervical vertebrae, but you have 8 cervical nerves. So you start above and you start below. Then you have 12 thoracic vertebrae, and you have 12 thoracic nerves. 5 lumbar, 5 nerves. So that's where the extra one comes in. I dearly love watching Star Trek and Spock and how he would do the Vulcan nerve pinch. But where he's pinching is over the trapezius nerve bundle, and pretty much that's not going to make you faint. You should know the parts of the spinal cord, and hopefully you've learned them in lab. If you can find the butterfly, right here's the butterfly, then that's one way of getting a point of reference. So the pointed part of the butterfly wing is known as the dorsal horn. And then if you come down from the dorsal horn, you've got the ventral horn. If you come over to the side, you have the lateral horn. And of course, you have the dorsal, the ventral, and the lateral horn over here. Now, it would make sense that the one that's on the inside would be the medial horn, but it's not. It's called the gray commissure. The gray commissure. And then right in the center, there's actually a canal. So that's your central canal. At the bottom, there is a very deep fissure all the way here. And it is known as your anterior median fissure, because it's in the front of the spinal column. So that would be anterior. It's in the middle, so median. And fissure because it's so deep. Now this is the posterior median sulcus, because it doesn't dip down. And then you have your meninges. These are the meninges around there. And the outer one is called the tough mother, which is the dura mater. And the one that's actually touching, right here, that's got the number 11, that's actually touching the spinal column, is called the loving mother, or the pia mater. And then the layer that you would think would be between the pia mater and the dura mater would be like the middle mater or something, but it's not. It's called the arachnoid. You know, like arachnophobia, spiders. It's the arachnoid. Now, in this particular picture, the arachnoid pulled away with the dura mater, and so you have a subarachnoid space here full of fluid around through there. If you're looking at this, you notice that this is darker and this is lighter. So this is considered to be white matter, and this is considered to be gray matter, right in through here, of which part of it is the gray commissure. So the white matter is also named kind of like the dorsal, lateral, and ventral horn. This is the posterior funiculus, the lateral funiculus, and the anterior funiculus. Posterior, lateral, and anterior funiculus. Now, just like the brain had 2 hemispheres, the spinal cord appears to have 2 separate halves. 2 points of interest about the spinal cord. Up in the cervical region, there is an enlarged area of the spinal cord. And again, down in the lumbar region, there's another one where it bulges. And then if you come down to the sacral region, you're actually going to branch off. And if you look at it, it looks like a horse's tail. And so the way you would say horse's tail is cauda equina. So there are the 8 spinal nerves along the 7 cervical vertebra. And then you come on down, there's your spinal cord, spinal cord, spinal cord. And then along about L2, you start branching out and branching out. And then down here in the sacral region, there's your horse's tail right there. And the very last little tiny bit of the spinal cord is the filum terminale. We'll talk about the meninges when we talk about the brain also, because these 3 layers of tough connective tissue surround the brain, and then they're continuous and come on down the spinal column. Here's how you spell dura mater, arachnoid mater, and pia mater. And in between the spinal column and the vertebra, there's fluid, and we call it epidural fluid in the epidural space. So you're probably familiar with this because when a woman is giving birth, they can put some numbing agent down in the epidural space just below the lumbar region so that it puts that area to sleep. And so the lady can still push. So the upper part is not numbed, but the part where the baby is going to come out, the nerves that would feel pain in that area are numbed. So it makes childbirth a lot easier on the mother. So most women know exactly what an epidural is. They may not know exactly where they're injecting that, but they know that it causes them to have a much less traumatic birth. So when the doctor says, you're going to feel a little pressure, that they always say when you have natural childbirth, these people actually won't feel the pressure and the pain. As we saw in that slice through the spinal cord, the arachnoid membrane kind of sticks with the dura. So it's almost like a double membrane. And there's usually fluid in between that and the pia mater. So that's your cerebrospinal fluid. If you're going to do a spinal tap, you go down in the lumbar region and you put a needle through into the arachnoid space and pull the fluid out. Subarachnoid space. As I mentioned earlier, if you go all the way to the end of the spinal column, you're going to get to the filum terminale, which is a fibrous ending point that fuses with the dura, which then forms the coccygeal ligament. So this is going to be the anchor at the bottom. Now, the cerebrospinal fluid is important because if you get too much fluid in there, it can cause brain damage. If you don't have enough fluid in there, then the brain stem and the spinal column can pull down into the foramen magnum. And so this is obviously not a good thing to do either. So it's amazing how we keep our cerebrospinal fluid at just the right amount to keep the brain suspended and to keep the vertebra from rubbing up against the spinal cord. Here's a picture putting all of that together that I was talking about. So you've got your epidural space here, and then you have your dura, and you have your arachnoid, and always touching the spinal cord will be your pia mater. And so there's your subarachnoid space in through there. And here your nerve is coming off. Here's your ganglion right there. This book has renamed things. So the dorsal horn, it is calling it the posterior horn, and the dorsal root, it's calling the posterior root, and the dorsal root ganglion, they're calling the posterior root ganglion. But in most every book that you look at, it's always going to be called dorsal. But since we know that dorsal and posterior are in the same orientation, then we're going to be okay with this. When you're looking at the white matter, what you're really looking at is myelin that's covering the axons. And when we're looking at the gray matter, we're looking at the neuron cell bodies, and they are not covered up with myelin. Remember that the white matter is called funiculi, and the gray matter are the horns. Here's a picture of a spinal tap, also known as a lumbar puncture. So the patient is laid down on their side like this, and usually you inject a numbing agent in there to help, and then you stick a needle in through and go into the subarachnoid space. So you're close to the horse's tail, the cauda equina. So we mentioned that you have some information going up to the brain, you have information coming back down. And so they talk about the ascending tracts with the sensory up and descending with the motor information coming down. But what's really interesting is, for some reason, you have decussation where you cross over so that one side of the brain is sensing the other side of the body. So that's contralateral. So the right side of the brain is controlling part of the left side of the body. This slide has way more in-depth information than we would need in an introductory anatomy class. So feel free to look over it, but I'll not ask you anything about it, except for I would like you to remember that the things that are going up to the brain are carrying sensory information up. They are afferent. And the things that are coming through the descending tracts that are taking the information down to the muscles, that would be the efferent that is causing an effect. Here's something you might find interesting about the spinothalamic tract. This is the one, it comes out in your anterior and lateral funiculus. Funiculi is plural. And it carries pain, pressure, temperature, light touch, tickle, and itch. But what's interesting, as it goes down the tract, it crosses over, and so it is contralateral, which means that if you're feeling a tickling sensation or heat, it'll register on the opposite side of your brain. So contralateral, the other side. And here's a picture of that one. So it shows you the connections through the brain, through the thalamus, down until you get down here and it crosses over. I find this interesting. Polio, its proper name is poliomyelitis, but we only just call it polio for short. It's caused by the polio virus. It destroys the motor neurons in the brainstem in the anterior horn. So that would be the ventral horn, the front of the spinal cord. I wonder why it doesn't attack the back. I find that very interesting. But anyway, signs of polio would be muscle pain and then weakness, loss of your reflexes, paralysis, your muscles deteriorate, they shrivel up, and then you end up being unable to breathe. One of our presidents, Franklin D. Roosevelt, was thought to have polio, but when they looked at the progression, the progression of polio goes in one direction, and the progression of Guillain-Barré goes in a different direction. And so now they know that he had Guillain-Barré, or Guillain-Barré, as some people call it, instead of polio. But it ended up leaving him in a wheelchair. I was born and lived in a time where we didn't have a polio vaccine. So a number of the kids that I knew had polio, and the lucky ones ended up with just leg braces where their legs didn't work anymore. But some of the others ended up where it went all the way up and they stopped being able to breathe. We didn't have public swimming pools with chlorine back then, so when we wanted to go swimming, we'd just find us a water hole, or even better, when it rained, we'd run down to the front of the yard where the drain was, where all the water would drain down, and they didn't have really good sewers or septic drainage at the time. So there would be big puddles of water at the end of our yard, and we didn't know that it was contaminated with fecal material. You know, we're just kids and it's fun and we jumped and played in it. But that's where a lot of the kids caught polio, by contaminated water, playing in contaminated water. We had almost wiped out polio, but now we're having anti-vaxxers and people who feel that vaccinations are dangerous and are hurting our children. And so there are a lot of people who have stopped vaccinating their children. And so we're seeing polio coming back, and it's horrific. Here's a picture of a child who had polio, and they put them in a chamber like this because they couldn't breathe by themselves. This machine pushed on them and caused them to breathe. They called it an iron lung. And there were whole wards full of children in these iron lungs. And they just laid there until they died. A horrible, horrible way to die. Since most people can't say amyotrophic lateral sclerosis, they either call it ALS or Lou Gehrig's disease, because he was a really popular athlete. And when he got it, everyone was just devastated because it's a death sentence when you catch it. Your motor neurons are destroyed, your muscles atrophy, they shrivel up, and then you have sclerosis, which is scarring of the lateral regions of your spinal cord. So that would be the outer regions of your spinal cord. So it's a blessing and a curse. It's a curse because you have muscular weakness. You soon lose the ability to speak. You have trouble swallowing. You can't use your hands. But your brain is unaffected and your senses are unaffected. So Stephen Hawking is the one person that most people now associate with ALS. And he just passed not too long ago. But he just decided to devote his life to studying physics. And he wanted to be the smartest person in physics in the entire world. And some say he made it. Remember that a nerve is a bundle of axons. So here we go. This is the spinal nerve. Here is the covering over it. And then inside you're going to find a number of axons. If you remember our prefixes, so the thing that would be on top of the nerve will be the epineurium, on top of the nerve. And then you have the perineurium, and then you have the endoneurium. When we did the muscles, we had the epimysium, the paramysium, and the endomysium. So this is the same thing, epineurium, perineurium, and endoneurium. Within that nerve, you can have afferent and efferent. You can have some that are sensory, carrying information in that direction, and some that are motor, that are carrying information to the muscles or the glands. You should definitely remember that the Schwann cells are the cells that wrap themselves around the axon and they make the myelin sheath. So when they talk about myelin or myelin sheath, you go, oh, that's the Schwann cells. And remember, the Schwann cells help faster depolarization. So if you damage the myelin sheath, you're going to have much slower nerve transmission. If you look at this picture, you also see these things right here. These are blood vessels. So you have plenty of blood coming in to nourish your axons. When they talk about the CNS, the central nervous system, they're talking about the brain and the spinal column. That's it, just the brain and the spinal column. This is a review of the other chapter. Sensory is afferent, motor is efferent, and you can talk to, or you innervate, muscles or glands. And you can have somatic or visceral. Visceral would be your guts, basically. This slide is just a reminder that ganglion are clusters of cell bodies, somas or neurosomas, whichever you want to call them, but they're cell bodies that are outside of the central nervous system. So they're not in the brain, they're not in the spinal column, but as you leave the spinal column, then you come out, you have the dorsal root, and then you have the dorsal root ganglion. And again, this book calls it the posterior root ganglion. If you cut a nerve, you can regrow the nerve. But if you cut into a ganglion, or if you cut into the gray matter, if you kill a nerve cell body or a neuron cell body, then it will not regenerate. Now, recently, literally in the last few months, there have been a few papers saying that they have found some neurons can regenerate. But I've not seen anyone who's repeated the study and found the same results. So all of your textbooks will tell you that if you lose the nerve cells, the neurons in the brain, they won't regenerate. And the same thing with the spinal cord. But if you just damage an axon, you can regrow the axons. If you have nerve damage and you're having to regrow an axon, it may take a while. The rule of thumb seems to be that if you haven't gotten back whatever senses, whatever feeling that you lost within 6 months, you may not get it back. The first cervical nerve is going to come out between the skull and the atlas, but all of the others are going to come out through the intervertebral foramina, so the holes in the vertebra. And here's that one, when you come to the very last bit of the spinal cord, then you come to the filum terminal, or the terminal filum, and there's where you're going to have the coccygeal ligament. The posterior root, the dorsal root, is sensory input. The anterior or ventral root is the motor output. So anterior is motor and posterior is sensory input. And then just randomly on this slide, they put that the cauda equina goes from L2, the second lumbar vertebra, all the way through the sacral region and ending up at the coccygeal ligament. The 5 plexuses are rather easy: the cervical plexus, the brachial plexus into the brachial region, and then the lumbar plexus, the sacral plexus, and the coccygeal plexus. Those are the 5 of the plexuses. Here's another really cool picture. So here you've cut away the vertebra, right there. So it's been cut away so that you can look in. And here is the fourth cervical spinal nerve. Right there, so you see it coming out, coming out, coming out. And then here's the fifth spinal nerve. When you take medical microbiology, you're going to learn about the herpes viruses. And you have genital herpes. Most people have heard of that. You have cold sores, which are herpes. But a lot of people don't realize that chickenpox is also a herpes virus. And one of the things that herpes is something that will stay with you for the rest of your life. So you don't get over it. It gets into your body, and then it remains for life in your posterior root ganglia. But your immune system usually keeps it in place. So if it tries to erupt from the posterior root ganglia, then the immune system fights it back. But if you're busy fighting cancer, if you're busy fighting pneumonia, if you're depressed and your immune system is depressed, then you can have it reappear later on as shingles. So chickenpox and shingles are the same thing, but they manifest a little bit differently. So if a kid who's not been vaccinated against chickenpox comes around an older person who's having a flare-up of shingles, they can catch chickenpox from their grandparents or whomever. And if an older person is around a kid who's got chickenpox, then they can have a flare-up of shingles. Here's a picture of shingles, and luckily I've never had it, but it'll follow the nerves. It'll follow the nerves, and it is unbelievably painful. And I think the most interesting case of shingles I ever heard of was David Letterman. He got shingles apparently in his optic nerve. Most older people didn't have chickenpox vaccinations because they didn't have them back then. We just got the disease, and we have the virus within our body. So they're recommending that older people get a shingles vaccination so that it'll help keep the virus from coming out of the posterior root ganglia. Here's a word that I expect you to know, proprioception. It's a kind of a complicated concept, but you're getting information from a bunch of different nerves throughout your body. And they're coming from muscles and sending messages to the brain, from your tendons, from your joints. And integrating all that information that the brain receives, it can tell what your body position is. Are you sitting down? Are you standing up? And this is one of the things that kind of gets muddled in older people. So they have a little trouble. They get dizzy very easily. Feel free to learn the names and the anastomosis, where these things come together. Like here's the hypoglossal nerve, which is cranial nerve number 12, coming down and joining with the first cervical spinal nerve. So here's a cranial nerve and a spinal nerve getting together. This is, again, way out of the coverage that we need to do in an intro anatomy class. Once the spinal nerves have exited the spinal cord, then they branch out, and we rename the nerves usually by what bone they run along. Here is the axillary nerve, and it is, of course, from the axillary region under your arm. Median nerve, radial nerve will be the one coming down towards the radial bone, which is where your thumb is. You have an ulnar nerve over here coming down towards your little finger. One of the things that they're seeing nowadays that it was fairly rare before is where the ulnar nerve is stretched because you're holding your mobile phone for a long period of time. So by doing that, remember your little finger, the ulnar nerve comes in that direction. So you're sitting there holding and wrapping around the little finger, holding the phone in place. And it's going to pinch the ulnar nerve. It's going to restrict blood flow to the ulnar nerve. And your little finger and your ring finger go numb. Here's a dissected cadaver showing you some of the nerves that you learned in lab, like the musculocutaneous nerve. And this one's going to go out and stimulate both the muscle, but it's also going to innervate the skin also. Musculocutaneous. There's your axillary, medial, radial, ulnar. And I put this in because I thought it was funny. She says, I married him because he made my feet tingle when we played footsie. Turns out it was just neuropathy. So one of the things that diabetics have a problem with is nerve damage. And they'll lose the feeling in their legs, their toes, and eventually, like my aunt, she had to have her legs removed because not only had she lost the feeling in her feet and her toes, but then the tissue started dying. When tissue starts dying, a lot of times then you end up with gangrene. So I had a friend who lost his leg to gangrene. He went in thinking they were just going to remove his toes, and when he came out, they had to cut off all the way up to his knee to get all of the dead tissue. If you're diabetic and you think you have neuropathy, of course you should see a doctor about it. But if you can take something that's not sharp but kind of pointed and rub it across your foot and your toes and you can still feel it, then you probably don't have neuropathy because it's actually a numbness. The median nerve is the one that's responsible for the numbness of carpal tunnel syndrome. And here's the part where you're going to feel it. Whereas if your little finger and your ring finger are numb, then that's going to be your ulnar nerve. So they actually have maps of your body showing which of the spinal nerves and which of the branches of the spinal nerves are responsible for the different areas of your body. I'm leaving these slides in because some people like to know more about things, but I'll not be testing you over this stuff. I would like to mention the sciatic nerve. It's the longest nerve in your body. So even though a neuron is microscopic, if you take a bundle of axons, you can actually see it. And this bundle of axons, this sciatic nerve, is actually up to 3 or more feet long. It extends all the way from up here all the way down to your big toe. So you can measure, if you're over 6 feet tall, then you know it's over 3 feet long. And if you're short like I am, it's a little bit less than 3 feet long. It causes a lot of old people a lot of problems. They get sciatica, and often it's because they're overweight, because they don't move around, or they sit, or they lay in bed too much. Here's the information about sciatica. 90% of the cases are from herniated intervertebral disc, so basically a slip disc, and or osteoporosis. So older people's bones dissolve and it allows the disc to slip, it allows the nerve to get pinched, and it results in a very sharp shooting pain. It goes from the gluteal region, so you remember that's your butt cheek, all the way down your posterior side of your thigh, so posterior is in the back, and down your leg and down to your ankle. So it's really easy to tell a sciatic nerve pinch. There's another, the radial nerve. It goes through your axilla so that if you are using a crutch, think about jamming that crutch up in your axillary region under your arm. So this is a radial nerve injury is common in people who have to use crutches. Your wrist drops down. So I found a cartoon about this, and this guy goes in thinking he has a pinched nerve, and he says, nope, it's just your underwear is too tight. And here is yoga poses to soothe sciatic nerve pain. So if it's pinching, if you can pull and push and get the pressure off, then it can stop some of that pain. But here's where the sciatic nerve goes, and that's the area where you're going to be having the shooting pain. Right there. And here's a picture showing where it's pinched. So you remember we have some sensory input that's coming into the spinal column, and we have sensory input that's leaving. So they've divided up the body into what they call the dermatome map. And the information, the sensory information, this shows which of the spinal nerves that the information will go to. And it said if you wanted to numb an area, a dermatome, then you'd have to numb 3 of the spinal nerves to succeed in it. Anesthetize 3 successive spinal nerves to produce a total loss of sensation in 1 dermatome. So if you're going to be an anesthetist, an anesthesiologist, by all means, learn about this stuff. So here's an overview of reflexes, and they require some sort of a stimulation, some sort of sensory input. They're very quick because they don't have to go up to the brain and ask permission and then come back down and do it. They just go right over to the spinal cord, and it sends the message right back out through the motor nerve saying, do this. So it could be a gland or it could be a muscle. It is involuntary. Again, you don't have to think about it. It just happens. It occurs without intent, and it's very difficult to suppress it. So a lot of times when you go to the doctor, they have the little hammer and they hit you on the knee, and they're looking for a particular stretch reflex in your patellar tendon. The incoming sensory information could be coming from your skin, the nerve receptors in your skin. It could be coming from your muscles, or it could be coming from your tendons. So wherever the input is coming, it's going to be afferent, carrying it to the posterior horn, the back, the dorsal horn of the spinal cord, or to the brainstem if it's high enough up. And you're going to have interneurons. They'll carry the information, and then it's going to come out through an efferent nerve fiber, carrying a motor impulse to the muscle or to the gland. I said that the knee jerk was the patellar tendon. I meant to say patellar ligament. Excuse me for that. So here's the patella right there. And they hit just below it, and it stretches that ligament right there, which causes you to kick outwards. Now, some people just don't have that reflex. I happen to be one of the people who doesn't have that reflex. So they sit and tap on my knee and look at me, and I don't do anything, and they tap again, and I don't do anything. And again, you don't repress it. It's not something that you can stifle it or say, oh, I'm not going to do that. It's involuntary, and some people are just missing it. So I'm just one of those people. When we did the muscles, this should look familiar to you, the epimysium and all of the things that we looked at. But we didn't talk about muscle spindles. So you've got fibers that are wrapped around in there that their job is to inform the spinal nerves, to inform the brain that you are stretching or contracting the muscle. It tells the muscle length and your body movement, what you're doing with your muscles. So I thought I would throw that in there. And don't forget the word proprioception. Proprioception means how your body is oriented in space. So you've got receptors that are going to send information to tell whether you're upright or laying down, whether you're spinning around in a circle, you're dancing, all those things. Here's another picture showing the muscle spindle. So there's your striated muscle. There's your Z bands. Remember Z line, Z disc, and the thin filaments and the thick filaments, the actin and the myosin sliding across each other. And here is the spindle that's sending the information to say this is contracting. I think it's funny looking at this slide because the person who did the slide and made the same mistake I made earlier. Your patella is held in place by the patellar ligament, and that's what you tap with a little hammer. And it says that your stretch reflex is usually mediated by the brain, but if you tap it, the tendon tap, you get a knee jerk. And he meant to say the ligament. If you have the time, pause the video and look over this because it is interesting. I'll not ask it of you, but you should know that if you tap on the patellar ligament, it will cause your foot to kick out. So it's called a knee jerk reflex. And if you really want to mess with your mind, look at this picture where you have a fellow who steps on a piece of broken glass on the beach. And so he's pulling his leg up, and it shows how this goes and how you have the crossover, because you're going to have to talk to these muscles in the other leg to keep you from falling over when you jerk this leg up. So it's kind of interesting to see the pathways. But again, I'll not be asking you that. Here you can tell this is an axon because look at the Schwann cells coming down. And here you are branching off from the end of the axon. So this is the axon terminal. And then if we could get really close, we would see bouton, but we don't see those. But look what it's innervating. Look what it's talking to. It's talking to a tendon. So we're used to it talking to a muscle or a gland or another nerve. And here it is talking to a tendon. So this is helpful if you're putting too much tension on the tendon, because you can actually apply enough tension, enough force, that you can tear your tendons or you can break the bone. So this this nerve innervation is to check and see how much you're stretching the tendon, how much pressure you're putting on it to keep you from contracting the muscle too much. So it moderates muscle contraction to prevent tendon tearing. I started out this talk today talking about spinal cord injuries, and so we're going to end up talking about them. Usually it's young males, and they're doing something in an automobile, risky, that causes a wreck, or having a motorcycle accident. It usually happens because they break the vertebra. And by breaking the vertebra, then they damage the spinal cord. Of course, we hear of our military and IEDs and some of the spinal injury that's caused there. So one of the things that I mentioned before, and I'll just bring it up briefly here, is if we did stem cell research, we should be able to repair these spinal cord injuries. We should be able to put stem cells in there and reconnect the spinal cords. if you break the spinal cord above C4, then you probably can't breathe. That's why I was saying you probably are going to die. You can be paraplegic, quadriplegic, paralyzed on only one side of your body. A lot of stroke victims have that problem. And paresis is where you have partial paralysis or weakness. So you're not paralyzed, but you certainly don't have full function of your arms and your legs. And then one of the things that I had not really heard that much about until I actually met somebody who had spinal shock. If you hit the ground suddenly, like people who their feet slip out from under them and they fall on the ice, or they get hit on the head by a falling object, it can cause spinal shock because it jams the spinal cord down too far and actually injures it. So you didn't break the vertebra, you don't have a slipped disc, you just have concussion on the top of your head or on the bottom of your spine, and it causes the spinal shock. So for these people, the one that comes to mind that I know of ended up in a wheelchair for over 6 months until they slowly got the nerve damage repaired and were able to walk again. So to end this talk, here's your spinal cord right there. There are your spinal nerves coming off. They've taken away the vertebra, so you can easily see them. Here's a cross section showing the dorsal horn, showing the tough mother, the dura mater, the arachnoid, the pia mater, the funiculus in the posterior, lateral, anterior, the dorsal, lateral, and ventral horns. And then there is your fissure right there. It is your anterior median fissure. And there is your posterior median sulcus. And when we get into the brain, you're going to learn that these are geary, little folds that stick up. And then the little crevasses, the little dips down in, those are sulci.